Hello everyone. In previous class, we discussed about what is the voltage to current and current to voltage converter, comparator circuits as well as Smith trigger circuit. पिछले वाली क्लास में हमने ये तीन टॉपिक कवर किए थे जो कि रिलेटेड है ऑपरेशनल एम्पलीफायर से। उसमें हमने स्टडी किया था कि वोल्टेज से करंट और करंट से वोल्टेज कन्वर्टर हम कैसे बनाएंगे और कैसे उसका यूज करेंगे। उसके साथ साथ हमने स्मिथ ट्रिगर और कंपैरेटर सर्किट को भी स्टडी किया था। Now in this lecture we will study about what is the characteristics of the operational amplifier, or we can say that the various characteristics of operational amplifier. After this we will move the next topic, name is active filters. इसके अलावा भी फिल्टर्स होते हैं, पैसिव फिल्टर्स होते हैं, बट आपके सिलेबस में ओनली एक्टिव फिल्टर्स दिया गया है, इसलिए आपको केवल एक्टिव फिल्टर ही स्टडी करना है। तो हम देखेंगे एक्टिव फिल्टर क्या होते हैं, कितने टाइप्स के होते हैं और कैसे ये काम करते हैं। नेक्स्ट वन इज अ ट्रिपल पाइप टाइमर एंड इट्स एप्लीकेशन। इसके बाद हम देखेंगे कि ट्रिपल पाइप टाइमर जो है वो क्या होता है, उसका बेसिक वर्किंग प्रिंसिपल क्या है, कैसे ट्रिपल पाइप टाइमर को हम बना सकते हैं ब्लॉक डायग्राम के साथ, और लास्ट में इसका एप्लीकेशन देखेंगे। And finally, the references of this presentation. So in this lecture, we cover all these topics one by one and complete unit number 5. तो स्टार्ट करते हैं टॉपिक 1 से, the various characteristics of operational amplifier. The characteristics of operational amplifier are as follow. तो ये सारे पैरामीटर्स होते हैं एक एम्पलीफायर से रिलेटेड। पहला जो है वो है डीसी ओपन लूप गेन, जिसको हम रिप्रेजेंट करते हैं AOL से। O मींस ओपन, L मींस लूप, और गेन को हम रिप्रेजेंट करते हैं कैपिटल A से। सो AOL मींस डीसी ओपन लूप गेन, जो कि आइडियल ऑपरेशनल एम्पलीफायर है वो उसका इन्फिनिटी होना चाहिए, और प्रैक्टिकल ऑपरेशनल एम्पलीफायर का जो होता है वो 100 dB होता है। dB means decibel. So this is the first characteristic. Second is a characteristics, और second parameter is input impedance. Impedance को हम represent करते हैं Z से, और input का है इसलिए Zin लिखा है। आइडियल एम्पलीफायर का जो होता है वो इन्फिनिटी होता है, बट प्रैक्टिकल ऑपरेशनल एम्पलीफायर का 2 मेगा ओम इनपुट इम्पेडेंस होता है। नेक्स्ट इज आउटपुट इम्पेडेंस, जिसको हम Z out से रिप्रेजेंट करेंगे। आइडियल कंडीशन में 0 होना चाहिए, बट प्रैक्टिकल में 75 ओम होता है। नेक्स्ट वन इज इनपुट ऑफसेट वोल्टेज, रिप्रेजेंट करेंगे VIO से। आइडियल ऑपरेशनल एम्पलीफायर का 0 होता है, और प्रैक्टिकल ऑपरेशनल एम्पलीफायर में 1 मिली वोल्ट होता है। नेक्स्ट इज स्लो रेट। स्लो रेट को रिप्रेजेंट करते हैं SR से, जो कि आइडियल एम्पलीफायर में इनफाइनाइट होते हैं, और प्रैक्टिकल एम्पलीफायर में जो स्लो रेट होती है वो डिपेंड ऑन दी इनपुट सिग्नल फ्रीक्वेंसी। तो स्लो रेट डिपेंड करती है आपकी इनपुट सिग्नल की फ्रीक्वेंसी कितनी है उस चीज पे। नेक्स्ट वन इज अ बैंडविड्थ, रिप्रेजेंट करेंगे BW से। आइडियल ऑपरेशनल एम्पलीफायर का बैंडविड्थ इनफाइनाइट होता है, बट इन केस ऑफ प्रैक्टिकल ऑपरेशनल एम्पलीफायर डिपेंड ऑन दी इनपुट सिग्नल फ्रीक्वेंसी। CMRR इसका फुल फॉर्म होता है कॉमन मोड रिजेक्शन रेशियो, जिसको रिप्रेजेंट करते हैं हम रो से, और जिसकी आइडियल में इसकी वैल्यू इनफाइनाइट होती है और प्रैक्टिकल में 90 dB होती है। तो ये पैरामीटर की एक शॉर्ट टेबल है। अब इन पैरामीटर को हम थोड़ा सा डिटेल में देखते हैं। सो फर्स्ट वन इज इनपुट इम्पीडेंस, रिप्रेजेंट करेंगे Zin से। An ideal operational amplifier has infinite input impedance to prevent any flow of current from the supply into the operational amplifier circuit. But when the operational amplifier is used in linear application, some form of the negative feedback is provided externally. Due to this negative feedback, the input impedance becomes Zin is equal to 1 plus AOL into beta into Zi, where Zin is the input impedance without feedback, AOL is the open loop gain, अभी हमने टेबल में देखा था, and beta is the feedback factor, 1 for voltage follower circuit. The impedance of the signal source connected to the input of the operational amplifier must be very much smaller than the amplifier input impedance to avoid signal loss. तो ये हो गया हमारा इनपुट इम्पीडेंस. नेक्स्ट वन इज the output impedance रिप्रेजेंट करेंगे Z out से. An ideal operational amplifier has zero output impedance. तो output impedance जो होता है आइडियल का वो zero होता है. This means that the output voltage is independent of the output current. Thus, an ideal operational amplifier can act as a perfect internal voltage source with zero internal resistance, so that the maximum current can be driven to the load. Practically, the output impedance of the operational amplifier is affected by the negative feedback and is given by Z out is equal to Z naught divided by 1 plus AOL into beta, where Z naught is the output impedance of operational amplifier without feedback, AOL is the open loop gain, and beta is the feedback factor. Load impedances connected at the output of the operational amplifier must be much larger than the circuit output impedance to avoid any significant loss of the output as the voltage drop across the Z out. So this is the output impedance of the operational amplifier. So next one is open loop gain, represent करेंगे AV naught से. The open loop gain of operational amplifier is defined as the gain of the operational amplifier when there is no feedback from the output to either of its input. From an ideal operational amplifier, the gain will be infinite theoretically, but practically value range from 20,000 to 2 lakhs. Next is a bandwidth. An ideal operational amplifier can amplify any frequency signal from DC to the highest AC frequencies. Thus, it has an infinite frequency response. Therefore, the bandwidth of an ideal operational amplifier should be infinite. In practical circuit, the bandwidth of operational amplifier is limited by the gain bandwidth product, GB. Next is a CMRR, means common mode rejection ratio. CMRR is defined as the ability of an operational amplifier to reject the common mode input signal. CMRR is an important measure of an operational amplifier. An ideal operational amplifier will have infinite CMRR. In practical circuit, CMRR is given by CMRR is equal to 20 log 10 into AD divided by mod AC in decibel, where AD is the differential gain and AC is a common mode gain of the operational amplifier. Next is a offset voltage represented by VI. The input offset voltage defines the differential DC voltage required between the input terminal to make the output 0 volt with respect to the ground. An ideal operational amplifier will have 0 offset voltage, whereas the practical operational amplifier shows some small offset. Next is a slew rate. Slew rate is defined as the maximum change of output voltage per unit time and is expressed as volt per second. An ideal operational amplifier will have the infinite slew rate. तो आउटपुट में जो मैक्सिमम चेंज हो रहा है पर यूनिट टाइम के रिस्पेक्ट में उसको हम स्लो रेट बोलते हैं. In practical operational amplifier, the slew rate is inherently limited by the small internal drive currents of the operational amplifier and also by the internal capacitance designed to compensate for high frequency oscillation. So these are characteristics of the operational amplifier. The next topic is active filters. So what is filter? Filters are electronic circuit that allow certain frequency components and or reject some other. You might have some across filter in network theory tutorial. They are passive and are the electric circuit or network that consists of passive elements like resistor, capacitor or an inductor. So next is the types of filters. Active filters are electronic circuit which consist of active element like operational amplifier along with passive element like resistor and capacitor. फिल्टर्स क्या होते हैं? एक्टिव फिल्टर्स वो होते हैं जो एक्टिव एलिमेंट जिसमें कनेक्ट होते हैं या कंसिस्ट करके रखते हैं उसको हम एक्टिव फिल्टर बोलते हैं. इसमें पैसिव एलिमेंट भी लगे होते हैं. Active filters are mainly classified into the following four types based on the band of the frequencies that they are allowing and rejecting. So the name of these type filters: number one, active low pass filter, active high pass filter, active band pass filter and active band stop filter. तो एक्टिव फिल्टर जो होते हैं वो बेसिकली चार टाइप से क्लासिफाई होते हैं. अब इनको हम थोड़ा सा डिटेल में देखते हैं एक एक फिल्टर. फर्स्ट वन इज कॉल्ड एक्टिव लो पास फिल्टर. इसको हम लो पास क्यों बोलते हैं पहले हम समझ लेते हैं. दिस इज द सर्किट डायग्राम फॉर एक्टिव लो पास फिल्टर. If an active filter passes only low frequency component and block all the other high frequency component, then it is called as active low pass filter. आपको बिल्कुल डेफिनेशन से समझ में आ गया होगा कि ऐसा फिल्टर जो केवल अलाउ करता है या पास करता है लो फ्रीक्वेंसी कंपोनेंट्स को, उसको हम लो पास फिल्टर बोलते हैं, और जो भी हाई फ्रीक्वेंसीज के अदर कंपोनेंट्स होते हैं उसको ब्लॉक करता है. द सर्किट डायग्राम for an active low pass filter is shown in a figure. We know that the electric network which is connected to a non-inverting terminals of the operational amplifier is a passive low pass filter. So the input of non-inverting terminal of the op amps is the output of a passive low pass filter. Observe that the above circuit resembles a non-inverting amplifier. It is having the output of a passive low-pass filters as an input to the non-inverting terminal of op amps. Hence, it produces an output which is 1 plus RF by Rn times the input present at the non-inverting terminals. We can choose the value of RF and R1 suitably in order to obtain the desired gain. At the output, suppose if we consider the resistance value of RF and R1 are as 0 ohms and infinite ohms, then the above circuit will produce a unity gain low pass filter output. Next is a active high pass filter. नाम से ही समझ में आ रहा है, ऐसा फिल्टर जो हाई फ्रीक्वेंसीज के सिग्नल्स को अलाउ करता है या पास करता है बट लो फ्रीक्वेंसी को ब्लॉक करता है, उसको हम एक्टिव हाई पास फिल्टर बोलते हैं. दिस इज द सर्किट डायग्राम फॉर एक्टिव हाई पास फिल्टर. इफ एन एक्टिव फिल्टर्स अलाउ पास ओनली द हाई फ्रीक्वेंसी कंपोनेंट्स एंड रिजेक्ट ब्लॉक्स all the other low frequency components, then it is called an active high pass filter. The circuit diagram for active high pass filter is shown in a figure. We know that the electronic network which is connected to a non-inverting terminal of an operational amplifier is a passive high pass filter. So the input of non-inverting terminal of operational amplifier is the output of passive high pass filter. Now the above circuit resembles a non-inverting amplifier. It is having the output of a passive high pass filters as an input to non-inverting terminals of op amps. Hence, it produces an output which is 1 plus Rf by R1 times the input present at its non-inverting terminals. We can choose the value of Rf and R1 suitably in order to obtain the desired gain at the output. Suppose if we consider the resistance value of Rf and R1 as 0 or infinity ohms, then the above circuit will produce a unity gain high pass filter output. The next one is active band pass filter. So this is the circuit diagram for active band pass filter. If an active filter allow pass only one band of frequencies, मतलब ऐसे फिल्टर जो केवल एक ही बैंड फ्रीक्वेंसी की जो है पास करता है, बाकी बैंड्स को ब्लॉक करता है, उसको हम बैंड पास फिल्टर बोलते हैं. Then it is called as an active band pass filter. In general, this frequency band lie between the low frequency range and high frequency range. So, the active band pass filter rejects or blocks both the low and high frequency components. Particular एक बैंड जो हम सिलेक्ट करेंगे उसी सिग्नल को ही या उसी जो है सिग्नल्स को पास करेगा और बाकी को रिजेक्ट करेगा, मतलब ये लो फ्रीक्वेंसी और हाई फ्रीक्वेंसी दोनों को ही रिजेक्ट करेगा. The circuit diagram of an active band pass filter is shown in a figure. Observe that there are two parts of the circuit diagrams of active band pass filter. The first part is an active high pass filter, while the second part is an active low pass filter. The output of the active high pass filter is applied as an input of the active low pass filter. That means both the active high pass filters and active low pass filters are cascaded in order to obtain the output in such a way that is contain only a particular band of frequency. अगर मुझे एक particular band of frequency ही filter करनी है या output में चाहिए है तो उसके लिए क्या करना पड़ेगा, active high pass filter और active low pass filter को ऐसे connect करना पड़ेगा जिसको हम बोलते हैं cascading arrangement. The active high pass filter, which is present at the first stage, allow the frequencies that are greater than the lower cutoff frequencies of active band pass filters. So, we have to choose the value of RB and CB suitably to obtain the desired low or lower cutoff frequencies of the active band pass filter. Similarly, the active low pass filter, which is present at the second stage, allow the frequencies that are smaller than the higher cutoff frequencies of the active band pass filter. So, we have to choose the value of RA and CA suitably in order to obtain the desired higher cutoff frequencies of the active band pass filter. Hence, the circuit in the diagram discussed above will produce an active band pass filter output. Next is an active band stop filter. In an active filter rejects block a particular band of frequencies, then it is called as an active band pass filter. नाम से ही समझ में आ रहा है, ऐसा फिल्टर जो एक particular band frequency को block कर देगा या stop कर देगा. So this filter is known as active band stop filter. This frequency bands lie between the low frequency range to high frequency range. तो ये जो frequency band है वो lie कर सकती है low से high frequency के बीच में. So active band stop filters allow both low and high frequency components. The block diagram of active band stop filter is shown in a figure. So this is the diagram. This is active low pass filter and active high pass filter combined with summing amplifier and get the output. Observe that the block diagram of an active band stop filter consists of two blocks in its first stage, an active low pass filters and an active high pass filter. The output of these two blocks are applied as input to the blocks that is present in the second stage. So the summing amplifier produces an output which is the amplified version of sum of the output of the active low pass filters and the active high pass filter. Therefore, the output of the above block diagram will be the output of an active band stop. When we choose the cutoff frequencies or low frequency filter or low pass filter to be smaller than the cutoff frequencies of a high pass filter. The circuit diagram of an active band stop filter is shown in a figure. So this is the circuit diagram. प्रीवियस वाला देखा था वो ब्लॉक डायग्राम था और ये इसका सर्किट डायग्राम है. We have already seen the circuit diagram of an active low pass filter, an active high pass filter and a summing amplifier. Observe that we got the above circuit diagram of active band stop filter by replacing the blocks with the respective circuit diagrams in the block diagram of an active band stop filter. So this is all about regarding active filters. The next topic is 555 timer and its application. So the first point is introduction to 555 timer ICs. IC means integrated circuit. So the 555 timer IC was introduced in the year of 1970 by Signatic Corporation and gave the name SE/NE 555 timers. It is basically a monolithic timing circuit that produces accurate and high stable time delays or oscillations. 555 timer क्या करता है? Provide करता है accurate and highly stable time delay or oscillation. When compared to the application of an operational amplifier in the same area, the 555 IC is also equally reliable and is cheap in cost. Apart from its applications as a monostable multivibrator, astable multivibrator, our 555 timers can also be used in DC to DC converters, digital logic probes, waveform generator, analog frequency meter and tachometer, temperature measurement and control devices, voltage regulator etc. इतनी सारी जगह जो है वो 555 टाइमर का यूज होता है. The timer's IC is set up to work in either of two modes, one short or monostable or as a free running or a stable multivibrator. The SE555 can be used for temperature range between 55 degrees Celsius to 125 degree. The NE555 can be used for the temperature range between the 0 degree to 70 degree Celsius. तो ये इनका टेम्परेचर रेंज है इन 555 टाइमर आईसीज का, SE और NE का. नेक्स्ट इज द इम्पोर्टेंट फीचर्स ऑफ द 555 टाइमर्स. अब 555 टाइमर्स के कुछ इंपॉर्टेंट फीचर्स हैं वो हम देख लेते हैं. इट इज ऑपरेट फ्रॉम अ वाइड रेंज ऑफ पावर सप्लाई रेंजिंग फ्रॉम +5 वोल्ट टू +18 सप्लाई वोल्टेज. मतलब 5 वोल्ट से लेकर 18 वोल्ट तक हम इस टाइमर को यूज कर सकते हैं. सिंकिंग एंड सोर्सिंग 200 मिलीएम्पियर ऑफ लोड करंट. The external component should be selected properly so that the timing interval can be made into the several minutes along with the frequencies exceeding several hundred kilohertz. The next is the output of a 555 timer can be drive a transistor logic, in short TTL, due to its high current output. It has a temperature stability of 50 parts per million, in short ppm, per degree Celsius change in temperature or equivalently 0.005% per degree Celsius. The duty cycle of the timer is adjustable. The maximum power dissipation per package is 600 milliwatt and it triggered and reset input has logic compatibility. More features are listed in the data sheet. और इसका जो डेटा शीट है उसमें और भी ज्यादा इसके फीचर्स हमें देखने को मिलेंगे. The next is IC pin configurations. So this is the 555 timer IC. ये जो 555 टाइमर IC होती है हमारा टॉप व्यू ऑफ मेटल कैन पैकेज एंड 8 पिन DIP. ये 8 पिन की DIP है 555 टाइमर का और ये हमारा टॉप व्यू है मेटल पैकेज का, है ना. दोनों में ही हमारे पास 8 पिन्स होती हैं. 8 पिन के अलावा 14 पिन का भी 555 टाइमर्स आता है. तो अब हम इन पिन्स के बारे में डिटेल में पढ़ेंगे कि ये पिन डायग्राम क्या होता है और पर्टिकुलर पिन किस चीज के लिए या किस फंक्शन के लिए बनाई जाती है या कौन सी पिन से कौन सा ऑपरेशन परफॉर्म होता है. The 555 timer IC is available as an 8-pin metal can, an 8-pin mini dip. Dip means dual in package, or a 14-pin dip. The pin configurations is shown in the figure. This IC consists of 23 transistor, 2 diode and 16 resistors. The use of each pin in the IC is explained below. The pin numbers used below refer to the 8-pin DIP. मतलब हम अभी जो डिस्कस करेंगे वो हम इस DIP के बारे में डिस्कस करेंगे क्योंकि मैक्सिमम जगह यही हमारा पैकेज जो है वो यूज होता है, मींस डुअल एंड पैकेज सिस्टम. एंड 8-pin metal can be packaged. These pins are explained in detail and you will get a better idea after going through the entire lecture. So the pin number 1 name is grounded terminal. All the voltage are measured with respect to the ground terminal. So we require a grounded terminal. इसको हमने pin 1 बोला है. Pin 2 is the trigger terminal. The trigger pin is used to feed the trigger input as the 555 IC is set up as a monostable multivibrator. This pin is an inverting inputs of our comparators and is responsible for the transition of flip-flop from set of reset. The output of the timer depends on the amplitude of the external trigger pulse applied to this pin. A negative pulse with a DC level greater than VCC by 3 is applied to this terminal. In the negative edges, as the trigger passes through VCC by 3, the output of the lower comparator becomes high and the complementary of Q becomes 0. Thus, the 555 timer IC output gets a high voltage and thus a quasi-stable state. So, the second pin is basically used for the triggering purpose or the name is trigger terminals. Next one is pin 3. Pin 3 is the name is output terminal. The output of the timer is available at this pin. इस पिन पे क्या होता है? आउटपुट अवेलेबल होता है. There are two ways in which a load can be connected to the output terminal. One way is to connect between the output pin, pin 3 and the ground pin, pin 1 or between pin 3 and supply pin, pin 8. The load connected between the output and ground supply pin is called the normally on load and that connected between the output and ground pin is called the normally off load. Next is a pin 4, name is reset terminal. Whenever the timer IC is to be reset or disabled, A negative pulse is applied to pin 4 and thus its name as a reset terminal. The output is reset irrespective of the input conditions. When this pin is not to be used for a reset purpose, it should be connected to plus VCC to avoid any possibility of false triggering. जब हम इसके लिए रीसेट के लिए यूज नहीं करते तो इसको हम कनेक्ट कर देते हैं प्लस VCC से, ताकि हमारी जो फॉल्स ट्रिगरिंग है वो हमारे टाइमर में ना हो. Next one is a pin 5, the control voltage terminal. The threshold and trigger level are controlled using this pin. The pulse width of the output waveform is determined by the connecting of pot or bringing in an external voltage to this pin. The external voltage applied to this pin can also be used to modulate the output waveform. Thus, the amount of the voltage applied to this terminal will decide when the comparator is to be switched and thus change the pulse width of the output. When this pin is not used, it should be bypassed to ground through a 0.01 microfarad to avoid any noise problem. Next, pin 6, name is a threshold terminal. So this is the non-inverting input terminal of the comparator 1, which compares the voltage applied to the terminal with a reference voltage of 2/3 VCC. The amplitude of the voltage applied to this terminal is responsible for the set state of flip-flop. When the voltage applied in the terminal is greater than 2/3 into VCC, the upper comparator switched to plus Vset and the output gets reset. Next is a pin number 7, name is discharge terminal. This pin is connected internally to the collector of the transistor and mostly a capacitor is connected between this terminal and grounded. It is called discharge terminal because when the transistor saturates, capacitor discharge through the transistor. When the transistor is cut off, the capacitor charges at the rate determined by an external resistor and capacitor. Next, pin number 8, this is the last pin, name is supply terminal. A supply voltage of plus 5 volt to plus 18 volt is applied to this terminal with respect to the ground, means pin 1. So this is the 8 pin, its function and its name. अभी हमने देखा 8 पिन के बारे में क्या क्या नाम है और क्या क्या इनके काम है. Next is a 555 timer basics. The 555 timer combine a relaxation oscillators, 2 comparators and RS flip-flop and a discharge capacitor. So this is the diagram for RS, or we can say that SR flip-flop. As shown in a figure, the 2 transistors T1 and T2 are cross-coupled. The collector of the transistor T1 drives the base of the transistor T2 through the resistor RB2. The collector of the transistor T2 drives the base of the transistor T1 through the resistor RB1. When one of the transistors is in the saturated state, the other transistor will be in cutoff state. If we consider the transistor T1 to be saturated, then the collector voltage will be almost 0. Thus, there will be a 0 base drive for transistor T2 and will go into the cutoff state, and its collector voltage approaches plus VCC. This voltage is applied to the base of T1 and thus will keep it in saturation. Now, if we consider the transistor T1 to be in the cutoff state, then the collector voltage of T1 will be equal to plus VCC. This voltage will drive the base of the transistor T2 to saturation. Thus, the saturated collector output of the transistor T2 will be almost 0. This value, when feedback to the base of the transistor T1, will drive it to cutoff. Thus, the saturation and cutoff value of any one of the transistors decide the high and low value of Q and its complement. By adding more components to the circuit, an RS flip-flop is obtained. The RS flip-flop is a circuit that can be set the Q output to high or reset it low. Incidentally, a complementary output Q is available from the collector of the other transistor. The schematic symbols for a SR flip-flop is also shown in a figure. The circuit latches in either the Q state or its complementary state. A high value of S input sets the value of Q to go high. A high value of R input reset the value of Q to low. The output Q remains in a given state until it is triggered into the opposite state. Next is a basic timing concept. From the figure, assuming the output of the SR flip-flop Q2 be high, this high value is passed onto the base of the transistor and the transistor gets saturated, thus producing a zero voltage at the collector. The capacitor voltage is clamped at ground. That is, the capacitor C is shorted and cannot charge. So this is the circuit diagram for 555 IC timing circuit. The inverting inputs of the comparator is feed with a control voltage and the non-inverting input is feed with a threshold voltage. With RS flip-flop sets, the saturated transistor holds the threshold voltage at 0. The control voltage, however, is fixed at 2/3 into VCC, that is at 10 volt because of the voltage divider circuit. Suppose that a high voltage is applied to the R input. The reset the flip-flop R output Q goes low and the transistor is cut off. The capacitor C is now free to charge. As this capacitor C is charged, the threshold voltage rises. Eventually, the threshold voltage becomes slightly greater than 10 volt. The output of the comparator then goes high, forcing the RS flip-flop to set. The high Q output saturates the transistor and this quickly discharges the capacitor. An exponential rise is across the capacitor C and a positive going pulse appears at the output Q. Thus the capacitor voltage VC is exponential while the output is rectangular. This is shown in a figure. Now next is a block diagram of 555 IC timer. So this is the block diagram for 555 IC timer. ये 8 पिन हम इसमें देख सकते हैं. ये जो रेड कलर की इनसाइड आपको दिख रहा है, दिस इज द ब्लॉक डायग्राम. और ये पिन नंबर 1, 2, 3, 4, 5, 6, 7 एंड 8, ये 8 पिन आप इसमें देख पा रहे हैं जो कि हमें एक्सटर्नली दिखती हैं. और ये सर्किट डायग्राम हमें नहीं दिखता क्योंकि ये इंटरनल सर्किट डायग्राम है. द ब्लॉक डायग्राम ऑफ a 555 timer is shown in a figure. A 555 timer has two components which are basically two operational amplifier, an RS flip-flop, two transistor and a resistive network. तो ब्लॉक डायग्राम के अंदर क्या होता है, दो हमारे पास एम्पलीफायर होते हैं, दो ट्रांजिस्टर होते हैं और एक हमारे पास SR फ्लिप फ्लॉप या RS जो है फ्लिप फ्लॉप होता है। So resistive network consists of the three equal resistors and act as a voltage divider. Comparator 1 compare threshold voltage with a reference voltage plus 2/3 VCC volt. Comparator 2 compares the trigger voltage with a reference voltage plus 1/3 into VCC volt. Output of both the comparators is supplied to the flip-flop. The flip-flop assumes its state according to the output of the two comparators. One of the two transistors is a discharge transistor or which collector is connected to the pin number 7. This transistor saturates or cut off according to the output state of the flip-flop. The saturated transistor provides a discharge path to a capacitor connected externally. Base of another transistor is connected to the reset terminal. A pulse applied to this terminal reset the whole timer irrespective of any input. So the next is a working principle of 555 timers. The internal resistance acts as a voltage divider network providing 2/3 volt VCC at the non-inverting terminal of the upper comparators and 1/3 VCC at the inverting terminal of the lower comparators. In most applications, the control input is not used so that the control voltage equal to plus 2/3 VCC. Upper comparators has a threshold input pin 6 and the control input pin 5. The output of the upper comparator is applied to set as input of the flip-flop. Whenever the threshold voltage exceeds the control voltage, the upper comparators will set the flip-flop and its output is high. The high output from the flip-flop when given to the base of the discharge transistor saturate it and thus discharge the transistor that is connected externally to the discharge pin 7. The complementary signal output of the flip-flop goes to pin 3. The output available at pin 3 is low. These conditions will prevail until lower comparator triggers the flip-flop. Even if the voltage at the threshold input fall below 2/3 volt VCC, that is, upper comparator cannot cause the flip-flop to change again. It means that the upper comparators can only force the flip-flop's output high. To change the output of the flip-flop to low, अगर अब low करना है तो क्या करना है? The voltage at the trigger input must fall below plus 1/3 VCC. When this occurs, the lower comparator triggers the flip-flop, forcing its output low. The low output from the flip-flop turns the discharge transistor off and force the power amplifier to the output high. This condition will continue independent of the voltage on the trigger input. Lower comparator can only cause the flip-flop to the output low. From the above discussion, it is concluded that for the having low output from the timer 555, the voltage of the threshold input must be exceed the control voltage or plus 2/3 VCC. This also turns the discharge transistor on to force the output from the timer high, and the voltage of the trigger input must drop below plus 1/3 VCC. This turns the discharge transistor off. A voltage may be applied to the control input to change the labels at which the switching occurs. When not in use, a 0.01 nanofarad capacitor should be connected between the pin 5 and grounded to prevent the noise coupled onto this pin from causing false triggering. Connecting the reset pin number 4 to a logic low will place a high on the output of the flip-flop. The discharge transistor will go on and the power amplifier will output a low. This condition will continue until reset is taken high. This allows the synchronization or resetting of the circuit's operation. When not in use, reset should be tried to plus VCC. The next is the applications of 555 timer circuit. The monostable multivibrator, it's worked as a one-shoot pulse generator. Second is a astable multivibrator, it works as a free-running pulse generator, or we can say that the oscillator. Next is a bistable multivibrator, it worked as a flip-flop, or we can say that Smith trigger circuit. Some other application of 555 timers are found in, it is used DC to DC converters and digital logic probes. It is also used in waveform generator. By using this we can generate RAM square waves. Next, converts an analog voltage to a pulse length in analog to digital conversion. Next one is analog frequency meters and tachometer 555 timer is used. It is also used in pulse width modulation or pulse position modulation, in short PPM. It is also used traffic signal lights control circuit and temperature measurement and control devices. So these are some applications where the 555 timer IC is used. So this is all about regarding 555 timers. Finally, the references of this presentation. So these are the references. And thank you for watching this video.